First slide is just a picture of our car, which is a bit Marmite, it's fair to say, this generation of car. People either like it or not, but it's definitely a different looking Formula car. But we'll go into that in a bit more detail in a moment. So for those who don't really know, I'm sure plenty of people in here do, but let's go through it anyway for the sake of the presentation. Formula E has been around now for quite some time. It's in its 9th season, which started back in, when was it? Early this year. It seems like a long time ago to me, but it wasn't really that long. It's been a very tough few months. The pinnacle of electric motorsport since 2014, and the idea behind it is essentially to bring about more knowledge and I guess exposure to the world at large of what everyone's trying to do with electric cars, not least the manufacturers of them, of which we are one. There were many manufacturers involved at different stages, but the idea of the event is very different to traditional motorsport. Is the whole thing happens in one day, and that's for a number of different reasons, which we'll go into a bit later on. The whole business model is intended to capture a completely new market of fans, so rather than risk of sounding disparaging for those around my age and older, just picking up on the market of F1 guys and people who love noisy engines and loud things and obviously lots of nice and fun things, but idea being it's not all about that for this formula. It's about trying to capture new markets and families of people who live in urban areas only, and trying to encourage them to come to motorsport events. That's been the case since day one, and I think has had a reasonable level of engagement in many different cities. The idea behind that is when we travel to a city, there's quite a level of engagement at local government level or council level, you might call it if it was in the UK, to try and bring about awareness of the events. So when you arrive in a city airport, for example, then there will be these kind of lovely banners with Formula E written all over them and the major sponsors and so on. And I think in Jaguar's case, who's well known to quite a few people here, they sponsor quite a lot of events in quite a lot of the major cities that we go to. So there's a lot of engagement that's, let's say, brought about from that. And the fan engagement has also been part of the story of the championship, I think, since the very first season, where during the race itself or a little before, you can start voting for what you'd like your driver to have. And ultimately, that meant in the first few events, you could get an energy boost, which was only available if you won this sort of voting competition. And then in the more recent past, which is carrying on now, you have to drive offline in a Super Mario style to go and get more power to allow you to then overtake the guys who've just come past you again, because it literally is like driving offline. You lose some time, almost certainly some places, and therefore come back on again and gain it all back again and more. Well, that's the idea anyway. And it does kind of mix up the strategy a little bit, particularly with the cars we have at the moment. So again, we can go into that in a bit more detail later. But from an engineering perspective, it's also quite different to a lot of the Formula cars that certainly I'm familiar with. I think a bit the same as a lot of people here too, so it's not really at all the same as Formula One. So thanks for this graphic, Martin, well done. This is excellent. So they're primarily common hardware. Now, what that essentially means is the vast majority of what you can see here is not under the control of the manufacturers, which ultimately is one of which we are. So all of the crash structures, everything at the front of the car, the survival cell, everything to do with driver safety, all of the bodywork you see on the outside of the car, the tyres, the rims, all of the outboard suspension, everything about it is standard and the same for everybody. So they're put to tender for each generation of car, which is typically a 4-year cycle. And whoever wins that then supplies that to everybody. The addition in the latest car, which is kind of the most important aspect on the standard parts, is that there's now a front regeneration kit, which effectively means that we don't really use the front brakes much at all, or certainly not in races unless there's something dire going on like an overtaking manoeuvre. So ordinarily there's 600 kilowatts of regen now available. Just a little less than half of that is from the front of the car, a little more than half from the rear. And the area where we then work is the label where it says maximum regeneration here, so that patch of the car there, which is underneath the engine cover. So the structural housing, which is the main topic of this technical presentation later, the powertrain itself, so every joule of energy that we get from the battery and try and feed back to it is the kind of important parameter, if you like. There's a differentiator between all the manufacturers in Formula E. So that is where we spend a lot of our sort of NRE, our non-recurring costs, and ensure that year on year we make progress there. And it isn't all about hardware. I don't know if I press the next one, what happens now? Because you put a lovely brown on. Let's see, shall we? There we go. Yeah. So because of that, the focus of our world is very much what Martin's helpfully highlighted there. So in that area of the car is where we have our war, and most of that is actually hardware to start with in a 2-year cycle, where we effectively pick up on whatever technology we're allowed to apply in that area, which ultimately hasn't changed much over the last few years. It's become clearly a lot more refined. the way we go about things like transmission design, as highlighted by the past presentation, and a lot of other topics has been refined over the seasons as well. The amount of resource we put into those areas changes every time. But ultimately, the technology involved in the background is similar. Let's say it's obviously advancing year by year, and every 2 years we get to change the hardware. But the primary challenge really is that the software is completely free, and it's a lot more free than in most other Formula racing. So it means that almost event by event, we'll be looking to change either energy usage strategies, something to do with the controls of the car, basically ensuring that we tackle all of the regulation limits that we can, and sometimes go a bit over them, as I'm sure everyone else in the room may appreciate. In racing, that's always the case. You try and push the boundaries, and that's something that we all do. I think there's obviously a few people here who do this day on day, day in, day out in Formula One. It's a very typical story, but slightly different focus in Formula E, not least because the team size is quite a lot less, in most cases anyway, and the budgets are significantly less, even though Formula One has been, let's say, had its wings clipped quite a bit in the last few years. I think it's still 4 or 5 times more than our budgets, typically, something like this. So the amount of money available to play in our relatively small playground is a lot less as well. I was going to say what happens next. I'm going to put this on. That's good. Well done. So the tracks are typically completely Formula E biased. I think the exception to that is one that we've just been to. If you were watching it at the weekend, then Monaco is the only track where it overlaps completely with another motorsport, which you might have heard of. But typically they are completely different tracks made from scratch in the events. Now that means there's quite a lot of more unpredictability or less predictability, whichever way around you want to say it. And that's even with quite significant investment in simulation tools. So for example, we'll know quite a lot about the road surfaces, but if they find something when they do the track walk on, I don't know, a few hours before the event even comes up now, then something will be changed overnight, and then you'll have to go and try and do all this work again at short notice. So there are quite a lot of variables that you wouldn't typically find in other formulae as well. And that's kind of reflecting the same topic about the one-day event format, where ultimately the operation of the cars is super important. So if you have any kind of what I'd technically describe as a fuss at any point during the day, it kind of means that you end up compromising in some way the driver preparation, the seat time he has, what he can do to optimize his use of the track, the car. And that really does have an impact throughout the whole day, because the sessions are so short. Nothing more than half an hour per session is now valid in Formula E, and qualifying is, I think, 12 minutes long, so there's not really a lot of time to have mistakes and then recover from them properly. Or rather, if you do have them, then having all the tools in the background to try and do so is really important. So that's a bit of an introduction to Formula E itself, and then a fairly short slide on why Mahindra in Formula E. I think it's a fairly familiar story to the manufacturers in Formula E as to why we're here, ultimately to try and ensure that we can transfer some of the things that we're learning, primarily about energy usage and efficiency of electric powertrains, across to the road car world, because a lot of people may not know, but they're actually a fairly decent sized manufacturer in India particularly. At the moment, a lot of agricultural vehicles are clearly they're not electric, but the point being over the next few years that needs to be the case. So there's a lot of IP being shifted around between us and them to ensure that we work on those topics with them. And I guess the only other topic to mention, which is I guess becoming a bit more valid as the longer the championship goes on, is we're the only founding Formula E team that's remained with the full manufacturer ownership throughout since just prior to season 1. I think we're also like the second team to sign up to it in the first place. So I guess that kind of means we are playing the long game by definition, which is a good thing to be proud of. And then we go on to the GRN bit of the presentation, which is, I guess, been put together with a lot of input from both Mandy and Martin, so thank you for that. Some of this stuff is really quite old because we've known each other quite a while. So ultimately, the reason why we use GRM is because we don't have internal resource to do this kind of work, and we don't really want to have it, because typically on the cycle that we have, where we get to change the hardware every 2 seasons, it doesn't really justify itself for the structure that we work on, which we'll see in a moment. So the roots of this work goes back to when I think I was working with Christoph, who's here somewhere, on this thing, which was a Red Bull chassis, but it doesn't say so there for obvious reasons. On trying to work to beat what Nastran could do at the time, and a lot of manual work with 73 lines of Excel. So from that point onwards, I think we've not really looked back in terms of doing optimization results, whether it be orientation or thickness, and then stack optimization as well, all of which are tackled in the next few slides. I think that covers that one. Okay, fine. So the development workflow is, I think, fairly typical for motorsport. I think it gets followed by many other people too, so I won't kind of spend too long on this. If I just flick through these lovely animations, because then I can read them otherwise. I won't know what's coming next. There we go. So we start off with some shape optimization, and that will show in a moment with some pictures. And effectively that means we've kind of defined a volume outside which we don't want lumps of things to be. And then inside that, we've put some no-go areas. Typically in our case, that's for small items like the gearbox and the motor and the inverter, so all the things that we can't avoid having inside. And part of the regulations as well is that we can't actually have anything impinge on that area when there are bad things happening outside, like crashes, hitting walls, and so on. We need to make sure that the structure itself is robust enough to ensure that if we have big crashes, there's not the chance of having a suspension piece, for example, come into the inverter and cause a high voltage link. So that's one other topic which is perhaps a bit different to Formula One. So the early phase is done in this way, where we typically offer a solid model and then it tells us where it wants to put solid things inside, and then after that we go to the geometry being confirmed on the outside, and then the laminate itself is optimized to some degree for the skins of that to try and make it a fairly boring looking box on the outside, but then on the inside of that fairly complicated structures depending on what the freedom is that we have inside, which is again something that comes up in the later slides. And then beyond that, the refinement and laminate development is something that we don't have the resource to do really at all in-house, and that's something that is really very helpful to have GRM helping us with, because it partially automates the process between this step and the next, where again back in the bad days you'd have just done a really big list of things, tried to line them all up by hand and then work out which bits worked, which didn't, and then change some orientations manually, and then plonk it all into a spreadsheet and throw it across to a haunted engineer who'd try and work out how to make it. And nowadays, however, that is somewhat automated. It's obviously going to get better and better year on year, depending on the refinement of the work and the draping aspects that I know you touched on earlier. Again, in our case, the 3D shapes aren't too complicated, but in some I'm sure they are. The idea being we come up with a ply schedule and some total thickness information that allows the production engineers to ensure that we get what we want at the end. It's something to then work to from a 3D modelling perspective before we make the component. And these are all things that happen in tight enough time frames, let's say, so that we don't really have the luxury of making one and working out what it looks like before we carry on. So all of this process happens within, I think, less than 4 months overall, certainly, from end to end. And then the component is made within perhaps 2 to 3 months after that, depending on the complexity. So the loading scenarios we have to consider. Again, nothing too unfamiliar for a lot of people in here, I don't think, but basically there are some sign-offs from the governing body, the FIA. That typically they define the overall strength of the component. There are some on-track load cases which typically define the stiffness requirements in some areas as well as the overall strength of the parts. That's just by using the suspension links that are very simplified here, of course. We may in future move towards using a more complicated either super element approach for that, or the actual solid models of the parts themselves, but in this case we kept it fairly simple with just beam elements. And then there are some unit load cases which just help us track from iteration to iteration, more as in car by car, how we're dealing with the wheel deflections in general, and whether we're achieving what we want to in terms of stiffnesses. So the concept model format, which was already mentioned on the previous slide, does this go lovely if I press it again? Does it disappear? Okay. No. I think it catches that. We pretend that disappears, do we? It's fine. Okay, it is, yeah. So this is the solid model that we spoke about earlier on. So effectively that is the block of the component which we started with, from which we could then basically allow the machine to go off and work out what it wanted. The lumps of missing material are for obvious reasons in there to ensure that we can actually fit the parts to make the car go. And there's that bit. Oh, here we go. This is the one that's better. So after we'd done this phase, we defined the outer shape, and it then helped to ensure what we wanted on the inside was present. It gives us good indication of where not only would we add just thickness, but some 3D shapes. So this is something where in an ideal world, we'd go off and magically make that a thing in the real world, which we're getting towards overall, I think, in quite a lot of motorsport applications, certainly. But there are quite a few practical things still to have considered at this point, not least is that we can't fit all 3 things in that hole individually. So there were quite a few things to consider, which meant that, let's say this was diluted a bit, but it did allow us to get some good ideas about what to do with the back of this particular structure, which I think is on the next slide a bit. Yeah, so we ended up with a couple of different, let's say, bulkhead areas in familiar areas, I suppose, quite near the suspension mountings. And what this really meant was it allowed us to then focus our work on detailing up how to ensure they were put into the structure in a good way, to ensure that they don't just fall out when they are loaded, and minimise the use of adhesive and fixings where we can. So the front bulkhead area, which is spinning, that front bit, which is the big hole, and then now that bit there, that's something we tried to do foams with, which again a lot of people will be familiar with. So roller cell cores inside the laminate to ensure the stiffness was quite high in the bulkhead areas. Then the other two areas, one of which is a lateral brace for the suspension mounting, is just to stiffen the component, because that's the one that sees a lot of loading in one of the safety tests. And I think that's all to say on this one, really. Apart from the obvious, the thickness plot is on there for a reason, isn't it? Sorry. So the thickness spectrum on the right-hand side indicates, once this is completed, what thickness of laminate was indicated in each of these areas. You can see in the floor there's a red patch, and that's to pass one of the stiffness tests stipulated by the FIA, where we have to pretend we've hit the car on the ground, which happens very regularly, so it's a good low case. But anyway, there to ensure that the deflection is quite low. So if there's any interaction with surrounding components, we need to make sure there's no damage. And doing so with this stripe effectively meant we then added some more foam core in this area to ensure that it's stiff enough. I think the next slide shows, what we did with orientations. So in our case, we chose a couple of areas where we could use some unidirectional material, which again is fairly typical in motorsport, but perhaps a bit less so elsewhere. And the cloth orientations, because of that, are fairly simplistic. Again, you could argue there could be a lot more of those, and easily there could be, but in our case, particularly with this first work with GRM, we wanted to keep it relatively simplistic and ensure it was, let's say, easy-ish to make. So that's what we did, and it defined for us the rough areas of different thicknesses required for each of the different orientations. And the UD placements, as you see, are kept only in what we'd call the shoulder areas, which is to carry the crash load from front to back of the structure. And that's because at the rear here there's a standardised crash structure, but has to undertake a standard test where we really do throw that out the wall, and this structure has to absorb the energy, so the load has to go through this structure. And to do that in the most efficient way requires some unidirectional material, so that's why we have it in there. And then interpretation of the results. So quite a lot of the early stage is done by basically defining how small our patches want to be from a productionization point of view, and whether we want them to be, let's say, easy to measure using effectively a ruler on the mold, which is kind of where we were at this stage, or whether you go more complicated by having something that is defined perhaps by the draping tool that you've spoken about already, which again, we didn't get to that stage with this. We wanted quite easy, clean lines, so somebody making the job could literally measure with a ruler in the tool where they were in terms of position, front, back, up and down. So to do those boundaries is all in here, and then the draping analysis ensures that the orientations remain approximately correct as long as we get the seed point right, and typically that would be on the largest flat surface, but again, that's something we'd leave to the production engineers to decide. And then we can conclude a little bit about what's happened since the start of Formula E, I suppose. So if I talk about this aspect of it first, which is how much it's changed since it started, and then go through the conclusion afterwards. So the main topics really that have altered are the scope of work that we undertake is actually a little bit similar as manufacturers between all of the generations. There was more work that we had to do during Gen 2 in terms of the systems integration. That's something that's dropped away a bit during Gen 3. But ultimately the speed of the cars and mainly the power levels are the topic to probably pick up on the most, in that throughout the whole time, the races themselves have been focused on efficient energy use. And that's ever more the case now than ever, because the battery capacity is quite low on purpose. But ultimately in the first generation, we had to switch cars at half distance. So I think it was 15, 20 minutes into the race, literally the car would come in, human would jump out, jump into other car and drive out again, which if you ever saw one of those was a little bit odd. So it became like a pit stop war for a while, which was a bit strange. You know, a car that's supposed to last a whole race, but it couldn't. So we all had to carry around 4 cars for that, which is a, let's say, questionable, sustainable story. So for Gen 2, that was addressed, and in fairness to that car, I think was kind of the benchmark for where we now are in terms of the refinement of the championship. So able to do a 45 to 50 minute race fairly comfortably, with the spectacle being relatively good as well. And then you end up with really quite good racing where there's enough scope in terms of energy use to ensure that under braking zones and when you coast a bit less, which is when you're off the throttle but at the end of the straight, just not using energy, therefore sailing, if you want to call it that. It's 2 different terms, I suppose, for the same thing. All those topics came more to the fore during the end of Gen 1, but then during Gen 2 it became very much about that. And then the current cars are perhaps even more the same, where it's super important to ensure the energy strategies you have are effective. And that leads to, again, quite good racing, where there's always scope to do some overtaking manoeuvres without using a lot of energy, but there's definitely now a premium on energy use in the races, perhaps more than ever. And that's, I think, reflecting in the spectacle of the races, which is good. Whether it's the correct approach for what we want to do longer term, that's something that the high-ups in Formula E will be deciding, I think, in the next few years for the next generation of car. But ultimately, the impressive aspect is that the power is now quite a big number, particularly in regen, as you see there. So that's very nearly the 1,000 horsepower of regen, which does get hit in the races regularly, in qualifying all the time. And when you think of all the joules flowing around the car in the magic wires, it's quite impressive. Because literally there's nothing on the car that generates significant heat when it does that. So from the point of view of the difference between where we are and where a typical car will be when you're slowing down from not quite that speed, to be fair, but 270 or so, there's almost no heat generation of note that can't be taken directly in the cooling systems because the efficiencies are so high. So I probably won't bother talking about those things I've put there. No, it's fine. So the structural engineering aspects, the main point really is that the main structure on the car is the one that we've spoken about here. That's the only one where we have significant freedom. There's a reasonably constrained space in between the back of the car and the chassis area, or the rear crash structure and the chassis. But within that, there is reasonable freedom to do whatever we like. Depends on your priority as to whether we want to try and extract as much mass from that as we can, because there are lots of different ways of splitting up our perimeter. But in our supply perimeter, we have a relatively limited mass to play with. Now, that does mean you need to choose which things you focus on the most. And that's something, obviously, between all us manufacturers, we play around with each time we do a car. So there's no real, I'd say, correct answer, really. The balance is always there to be played with. And GRM help us do that. And don't think I've got anything else to add. But if you've got questions, I think we can do them at lunch or whenever we want. I don't mind. So, thank you.